Hi, I am Alan C. Smith, consulting software architect and 30-year LabVIEW veteran. I have all of 25 minutes, so I'm just going to dive right in with a question. I'm actually here to talk about some really common pain point that comes up in developing our applications and maybe some things that we can do about it. So first, a question. So does this happen to you guys? Like long project load times, you fire up your app, you sit down to start work one morning, you open up your project, get yourself a cup of coffee, read a short Russian novel, you come back, and maybe your project is loaded. Show of hands, who has that happen like daily? Yeah, all the frickin' time, right? Okay, what about my technical difficulties today? Oh, darn it. There we go. What about this? Build times take a long time. Yeah, long build times. And I recently learned from the LabVIEW Experiment podcast with Darren Nattinger, an hour is not a long build time. 3 is probably a long build time, right? Okay, do your builds randomly fail for no discernible reason? I'm not talking, oh, my block diagram's missing. I'm not talking, wow, I am all over the map today. I'm not talking, broken diagrams. I'm not talking missing dependencies. I'm talking just, screw you, we're not building today. Yep, okay. Do you have this happen, right? You sit down with your project and you want to work with maybe one of your base classes, and so you pull it into your application and you wind up pulling in the entire project. Yeah, okay. Would it surprise you to learn that these things are connected? Anybody surprised by that? No, they are all connected. This is a real thing. This is a real project that I inherited, okay? And I had to figure out what was going on. So I want to pull in this base class, see what it's doing, maybe write some unit tests. Well, that's right out the window. Okay, what are we fighting? What's going on here? A lot of you probably already know this. We are up against some real limitations in how LabVIEW loads things into memory. And it turns out that it does it a couple of different ways depending on your mode of operation. Did you just load a VI from Windows Explorer? Did you open up your project file? Is App Builder? App Builder apparently does its own things as well. This was, again, I was talking to Darren about this. Okay, so they actually all apparently have different code bases under the hood to make it all go. And we need to kind of understand this about this much, and I don't have deep knowledge of this, but I'm just aware of this. What we're actually doing, what's going on, is we're dealing with how we load stuff into LabVIEW. And if you just go to open up Windows Explorer, grab your top level VI, you load it, the entire VI hierarchy loads, no surprises there, all your sub VIs, all their sub VIs, et cetera, et cetera. If one of those sub VIs is in a library, common understanding was that you loaded the entire library. In this mode, that's not true. You really just load the one VI. Well, okay, cool. Classes, of course, if you grab a class method, you do load the entire class. So that's going on. Slightly different if you open your project. The projects load everything under the targets, right? If it's under the target, it gets loaded. If something under the target depends on it in a static link, that also gets loaded. Classes load in their entirety, like everybody else. Greg's throwing his hand up because I think he's going to be critical of something. Very quickly, because I'm going to take all of my 25 minutes.
Libraries do not load entirely. We load the library, but not its contents.
Okay, then you can explain this to me, because there is something going on. Because when you load a project, you've got to go look, and you've got to look up information for all the dependencies, and it's going to grab everything in the library when it does that. It's grabbing
something. It reads
something.
the dependencies off disk. It does not load the VIs.
Okay, well, so it's doing stuff. I will, obviously, I'm going to take Greg's deep knowledge on this. We'll correct that in a future version of this slide. As I said, I had a conversation with Darren, and we didn't quite get all the way into it. But you are going through, and you're doing all this dependency calculation, which is extra steps. Okay, so this can create a scenario where you've got long dependency chains, and this is what we're actually up against. This is the worst case. This is classes inside libraries. This is the worst it can be. I go load my top level VI. Okay, it happens to be in a class. I load the class. Class is in a library. That's going to link to my other classes. Well, okay, cool. I've got that class loaded as well. If that links to something else, I'm going to load, and I'm going to load, and I'm going to load, and I'm going to load. Okay, and so this is what LabVIEW is doing when it pulls your stuff into, especially heavily library-based, heavily class-based applications. You're loading a lot of stuff. And where you can really get in trouble, I mean, we're going to have this. This is unavoidable. This is just our code. But where you're really going to get into trouble is when you build in a cycle in the loading. So my PNID class loads something out of the device driver, which pulls all of its related stuff in, which loops back to my analysis, and I've got a cycle. I can start from any one item on this diagram. I can follow the arrows around and get back where I started. This is bad. This makes LabVIEW churn, and it has to cycle through. And again, I don't have deep knowledge of the compiler, but my understanding is it has to cycle through and check everything, check all your dependencies, make sure everything's rational, make sure everything can compile. And that can take a while. And the longer your chains and the more cycles you have, the worse this can get. And this is where we get those long load times. This is where we get pulling everything into dependencies. Okay, that's our reality on the ground. That's how the old girl works. We love her. We have to live with it. Now, you might think, oh, we got to write our code to deal with this. And you might think, oh man, that's annoying. This isn't cool architecture. This isn't something I can write about and come to GDevCon and tell you all about, and you're going to think this is really cool. This is not something that's going to ever check a box for a customer on their requirements. They're not requiring you to write decoupled code, but we need to do it in order to work effectively. And that's okay, because the entire point of architecture is to make our jobs easier as the people who develop, deploy, operate, and maintain software. And a long load time in the project, or a long build, or an unstable build process, that makes our jobs harder. So we need to learn to write our code not to do this. And I've talked a little bit about this on this stage 3 years ago, back in 21. I gave this presentation, which I'd actually given earlier. You can dive into this. You can dive into the book that Darren mentioned the other day. Probably has a lot of good tips on this. And go learn lots of detail on how to do this right for the code that we care about, the code that we expect to be linked together. There are actually techniques to make this better. I'm not going to talk about those today. I'm going to talk about the dumb things that we do that link our code together in ways that are highly undesirable and accidental. Let's deal with the low-hanging fruit. Take this presentation as a coda to Darren Nadiger's brainless things on the block diagram presentation. This is brainless things that we do without thinking that create these, add to these long cycles, add to these cycles that we can build in, these long chains and cycles. Okay. So, got this one from Darren as well. Did you know you can build a cycle inside your VIs? You wouldn't think it. They're not libraries, they're not classes. But you can have a VI that can call itself, right? Through recursion. Shared clone reentrant VIs can call themselves. And recursion's a powerful tool. Not telling not to do this. You can write some really cool algorithms, really efficiently solve some problems. Just understand what you've done. And understand that you can have long chains of recursion, right? Where I can have a long set of shared clone reentrant VIs, and I can start at the top, and they can call VIs and call VIs and call VIs and get to the bottom and cycle back. That's going to make the old girl cycle through all these things to make sure that she understands what's going on. Okay, so that's it for VIs. VIs are reasonably safe in this regard. Where we get into trouble is with libraries and with classes. And actually, I'm going to talk about typedefs in libraries and classes as a starter. I'm going to use a class example because that's where we tend to pull the most stuff come in. Say I have some class that I've written, and the class does some useful, does some work, right? Maybe I've got a case structure that I'm driving with an enumerated, which of course we're supposed to typedef because that's what you're supposed to do with your enums. I use it in several places in my code. It's a state variable for my class. Well, okay, it's a state variable for my class, so it's going to be in my class data, right, where it should be. And I think this is such a useful thing that I go ahead and make the typedef like I'm supposed to, and then I put it in the class. And we're still okay. This is still all right. Problem arises when I decide that I'm going to make that enum that type def available outside of my class for some reason, right? I didn't mark it private, and then I went and I wrote an accessor so that everybody else can set my state for me. And that is where it all goes horribly wrong. Because, I mean, that's going to be called, I'm going to call that type def by the thing that calls my class. That's okay. But this queued message handler is going to get a message from somewhere else to set my state, and it's going to use my useful enum, and it's going to have it in its private data. And this is a queued message handler that I don't think should know anything about my class at all anywhere. But I've built that link. Obvious answer, and for these really dumb ones, the answers are all obvious. Just put that enum somewhere else. Take it out of the library. Take it out of the class. Put it in its own library if you want to group them together, because they won't be loaded. They won't load the rest of the library, rather, or just put them in a folder. They can be loose. They're foundational, right? So that's an easy win. Here's another one that I got for real. When I was in systems engineering, I had a support request. Hey, my project takes 20 minutes to load. This guy didn't have any classes. I loaded up his project, and I found a top-level library after 20 minutes and talking to coworkers for a little while, right? That top-level library had nested libraries in it, which had nested libraries and VIs and so on through several levels of this. Oh, my heavens, why? Why would one do this? If I make a library is a declaration to, and this took 20 minutes. Really, this took 20 minutes to load. A library is a declaration to the world that these things in the library should be used together, should load together, and nothing else. Okay? It's an atomic unit. That's how you should think of it. So if I take my 2 atomic units and I put them in a library, I've now declared that that's 1 atomic unit. Why do I have 3 libraries? There's no value in nesting libraries like this. So don't do that. That's an easy one to avoid. Hopefully nobody has done that. By the way, it gives you really goofy qualified names if you actually do this. So, it's another reason not to do it. So that's an easy one to just not do. That's libraries. Classes are where it gets really exciting, where you can really start building up these long chains and these cycles if you're not careful. Here's another culprit that I have seen done. Early me may have done it once or twice before I learned better. I have class A and I have class C. I'm curious about class A. I pull it into an open project, and I pull in class C as a dependency. Why? I go look at class A. The control doesn't. I don't have class C as an attribute of the class. I don't. None of my methods. Have class C as an input or an output. What's going on? Well, I can go take a look at the class, I could go find its callers, and lo and behold, it is being called in this calculation method of class A. And I open up the calculation method of class A, and I find this little VI from class C in it. It's not using the class, it's just a little VI. It's this VI, it's this transform. It's pretty clear what happened. The guy who wrote class C wrote some math, thought the math was useful, stuck it in a VI, made it a helper method, didn't mark it as private. Somebody come along, wrote class A, said, I need that math, and just grabbed it. So this is another easy one. There's no, other than using this bit of math, there's no logical reason for these classes to be connected. By the way, this is what's going on in C, is using it in exactly the same way, as it turns out. Make a math library. I mean, it can be a loose VI, or you can stick it in a library, but just put it somewhere else. Take it out of class C. Then your dependencies go in the right way. A and C don't have any interaction with each other. I mean, you are connected to a math library, but in theory, that's foundational, doesn't call anything else. So hopefully you're done there. Here's another one that is, why did we do this? And again, this is from a real project. Class B is calling class A. This seems to make sense, right? B is using A in some manner, except it's using it very, very trivially. Class A has some data to share. So class A has a public accessor to get my value. Class B takes that data, does something with it, right? There's no reason at all for this arrangement to exist. We decided when we wrote class A that that data is public. So call it from the calling code. I got 5. How do I only have 5 minutes? 10 minutes. 10 minutes. 2 hands, 10 minutes. OK, I got 10 minutes. Cool. Yeah, so don't do this, right? This is real easy. Now, sometimes you do want to have a class use another class. That's a very common thing. This is a place where we're going to have coupling. And this is where it's appropriate. B is going to change A in some way. Yes, by all means, B should use A. A is somehow crucial to B's operation at a real level. In this case, I'm using a calculation of A, and maybe I want to change what that calculation is so I have different children of A, right? Or maybe I'm using data of B that has to be private for some reason. That's appropriate. Don't be afraid to do that. That's a place where you're going to have coupling that you can't avoid. Another one. I've done this one intentionally, knowing I was going to not do it anymore. I've seen this on a recent project where it was not intentional. It was very, very bad. I have a family of classes that I use for some purpose. They happen to be phonetic letters, Alpha, Bravo, Charlie, whatever, class representations of those. And I have this inheritance relationship, which is appropriate. And what I'm doing is maybe I'm converting a text string into an array of these phonetic letters. So I have this little pick VI. Given a letter input, I'm going to go ahead and pick the appropriate class, right? We do this sort of thing all the time. And it's fine until I put pick letter in the parent class. I have seen this. I said I've actually done it once or twice knowing I was going to change it, but I've seen it as permanent standing code. And why is this bad? Because now my parent is connected to all of my children. The arrows flow the wrong way, and I have multiple cycles. And of course, each of these children calls other code, and this, I swear to God, this is the reason I got this in my project. Because channel was linked to every instance. Channel had a factory method in it, and it created every child of channel in there. And they all linked to everything else, and that's what I did wrong. So don't do that. The answer, again, is, as often the case, pick letter belongs somewhere else. Okay? This is a bit of a rant. I inherited a legacy project. It had most of these things in it. I hit them again and again and again, and I thought I need to get the word out to not do these things. Slightly different, we were moving up the scale of complexity. The last thing I will briefly mention is our frameworks, because you can build coupling in there, and oftentimes it's coupling we have to have, but we can avoid making some obvious mistakes. When we're talking about frameworks in LabVIEW, we really have the two dominant ones, DQMH and Actor Framework. I will talk about Actor Framework first. It is the one with which I am most familiar. I have two actors, and you will note that in the structure of Actor Framework, it is a library containing classes. So this is the thing that can really build up our chains for us if we're not careful. And how you get a cycle with actors is I have my actor device, for this example, wants to update process variable, so it calls display temperature on the UI. That link is fine. I can turn around and go the other way. Of course, if I want to adjust temperature, I'm calling the change set point message of device. Now I have a cycle between my two actor libraries, and this is something that I desperately wish to break. The answer in Actor Framework is, of course, interfaces, for those of you familiar with classes and interfaces. So instead of having device and UI, having all that information, they each inherit from an interface. That interface is responsible for implementing their messages. So the interface itself is a package of messages in a class, kind of like the actors. But the nice thing about doing this is when device and UI call messages in these interfaces, the interfaces are foundational, there is no cycle here. You cannot start at new device, follow the arrows around, and end up at new UI, and vice versa. And this is what we want. I can pull one of these in. If I pull a new device, I'm going to get both interfaces. They're foundational. They shouldn't call anything else. And so that's going to get, that breaks that cycle. I am not a DQMH expert on this. I did talk to Darren about this to make sure that I had understood it. But the way DQMH works, DQMH has a very similar problem. Modules have requests, modules have broadcasts, and if my mains in my two modules call requests, Those are making VI calls in the other's libraries. Now I have my cycle arrangement again. I'll go previous. So what we want to do instead, right, there's my cycle relationship. We want to break that because, again, GQMH module, as we saw, is a library full of, it turns out, it's classes. And so that can get really wicked as well. So the answer here is to make sure things go in one direction and one direction only. You can go ahead and, M1 here can call module 2 requests. And it also registers for broadcasts from module 2, but that means it's calling, this is all the VI calls. I mean, logically, the data's moving back and forth and there's a cycle. But in terms of VI calls, everything's going from 1 to 2, and that's what we want. That breaks the cycle. It doesn't decouple completely. You still can have a long chain of module to module to module to module. But if you pay attention to this, you can avoid getting cycles and those really long load times. So that really is kind of like the key lesson here is to create no cyclic dependencies. Those are what kill you. We're going to a certain extent, if you're using a complex framework or using classes and libraries, you're going to have long chains, and they're not avoidable, but we really want to break the cycles as best we can, and we want to avoid dependencies where we can, because that'll make that engineering process easier. So, use recursion appropriately. Your type defs are foundationals. They are not class members. Your helper functions are foundational, not class members, unless they're private, right? Because your helper may know so much about the class it needs to be private. Don't nest your libraries. Simple data exchange between classes should be brokered by the user of the two classes, not by the classes themselves. Parents do not call children, ever. And decouple your higher level modules where you can. How best to do that is the subject of a different session. And so that is me at 24 minutes, 18 seconds. Y'all know where to find me. Let me know we saw me here. I'll take any questions that you have, I guess offline, because I'm basically out of time.
We got time for like 1 or 2 questions.
Yeah.
Have you found any tools or do you have any tips for finding those cyclic dependencies deep in a large project?
John McBee at the Craftsman blog had a tool that hasn't been serviced in a long time that will look up a lot of those for you. I don't have one. The best tool we have for finding dependencies is actually the project and the dependency section.
Can I feature request?
Yes.
Yeah, or somebody pick John McBee's tool and work on it, because that was actually pretty effective, but it's 8 years old at this point. Hasn't been touched in that long.
It sounds more like an open source request because it's a tool that benefits us. I do take offense with the not nested libraries because I have nested libraries in pretty large projects and they load fast and they build fast. The issue is the coupling and the circular dependency, which can cause the problem with the libraries.
Okay.
So the problem is not nested libraries because I've seen pretty...
So why do you nest libraries?
Because they have a way of separating the different units. It's another way of separating units that work together. And we even have DQMH modules. And I've said this, even when you have coupling, like for example, we've done a module where it's, a main module has the main screen and then the other modules, how do I describe this? So the other clonable modules are related, and those two modules will always work together. They will always go together no matter what project. So I want them, like if anybody of you has been in my classes, when I teach advanced architectures in LabVIEW, I'm Mexican, so I'm allowed to do this. If you invite a Mexican to a wedding, they're going to bring their whole family. So this is the same thing with a library. Well, you invite one VI in a library, and he's going to bring the entire family. And that's actually useful because the developer experience, the developer that is getting that VI gets to see all the other VIs in the family that could potentially be used for their product, for their project as well. So nesting libraries means I bring one VI, and I get everything I need to come with it.
That's the point of the library. As I said, the library is supposed to be an atomic unit. These things all go together. Obviously, a classic actor is putting the actor itself and all of its message classes in a library. We still do that with interfaces. this may be a philosophical distance. I'm still going to push back on there are other ways to show that these things go together. And I would still push back. I would still push back on the nested libraries. Now, are there exceptions? Sure. And I'm a big fan of all of my actors, for example, or interfaces these days. You know, Stephen Loftus-Mercer has pushed back on, as you say, a few cases where I have actors that go closely together, and at that point you can allow the coupling. There's still going to be some issues with cycles. It's still something that you've created.
I've got another example, by the way.
Nested libraries don't inherently decrease performance. It's really about the size of the entire tree of dependencies. So in that sense, even the cycles aren't really the core issue. The core issue is the size. Cycles couple things such that it's harder to find like independent subtrees within your dependencies. If you have a nice tree at any level of the tree, you know, the tree grows as you go up. But when you have a big cycle, it's like that one, any step you take to that level includes everything. So yeah, it all comes down to coupling. One concrete reason to do nested libraries is that each nested library defines its own access scope. So you can do some really good things with controlling exactly which parts have access to other parts, and then still have that all happening within an outer thing, which hides it all from the public. So there are use cases.
I don't know how. I see your point. I don't know how deep I'd want to go with that, though.
Yeah.
I think
An
there's probably
example.
yeah.
An example is actors. If you've got a couple of actors that are they're separate actors to be separate parallel processes, but they're all meant to be used together. Maybe they're hidden under the hood of some framework. If community scope didn't break in certain use cases, you could avoid it, but having private messages that aren't exposed to external callers, you can only do that effectively with library access scope. And since you want to put them together as a single unit and get the developer experience where they all come along together, you put them in a containing library.
But how deep is that going to go? I mean,
Like
I can
2
see,
layers.
Like, right, 2 layers. 2 layers I could see. But I mean, this project that I brought up for you, I mean, it was 3 or 4 or 5. I don't remember, it was years ago. It was deep, deep nesting, and it was just VIs. And anyway, so clearly we can have discussions about that. And to first order, it would be something I would be leery of, but I can see use cases. I think that's it.
All right, we are.